Anything in the words that you're not sure, like what the chemical formula is? Or did you know them all? Connor, tell me your chemical equation.
NaOH plus H2SO4. Is that sulfuric acid?
Yep, that's right.
Equals H2O plus NaSO4.
Na what, SO4? What's the charge on sulfate? Anybody? What's the charge on sulfate? 2 minus, so I need Na2SO4. Sodium's 1 plus. What else do I need to do? I have to put the state and I have to balance it. So I know these things are aqueous. Water, I use liquid. Everything else is aqueous. Rice, sodium sulfate's aqueous, yes? Yep. Okay. Now balance it. What do I have to do to balance it, Cole?
Double the sodium hydroxide in water.
Yep. Everybody get that? Okay, so now the next thing that I logically should do is find the molarity. My marker's dying. I want you to find the molarity of the H2SO4 because that's what you're given the information about. You are told that you have 47.5 milliliters of a 0.5 molar solution. So we know what our molarity is. We know how much of it we have. So I guess the real question we need to find out is how many moles of H2SO4 are present. So do that. We have to work with our sulfuric acid because it's the only thing we have information about, enough information about. So I have 0.5 moles in 1 liter. If I have 0.5 molar, that would be 0.5 moles in 1 liter, but do I have a liter of it? How much of it do I have in terms of liters? Yep, 0.04, is it 5.7? Yeah, 5.7 liters. So I can do the math and figure out what that is. 0.4. 0.0229 moles. Is that right? Okay, so now I found my moles of H2SO4. How can I use those to help me find out about my sodium hydroxide? Is that wrong, Lucas?
I don't know.
0.5 times. Yeah, that's right. How can I use this information to help me move forward? Thank you, mole ratio. So I know what is my stoichiometric equivalency here. 2 NaOH is stoichiometrically equivalent to 1 H2SO4. So I'm going to remember that and move it forward. So I have 0.0229 mole H2SO4, and for every 1 mole H2SO4 I have 2 mole NaOH. So now I can figure out how many moles of sodium hydroxide I have. I have 0.0458 mole NaOH. Now what can I do with that? And what I have left in my problem?
We can find the molarity.
I can find the molarity. What do I have to divide through by?
Later.
How many milliliters did I have? 20. That's how many liters? Answer me. How many liters?
20.2.
So I calculate that I have a 2.3 molar solution of sodium hydroxide after working through all my steps. What this titration and neutralization stuff does is it just puts everything together. Did I give you 2 problems? Oh, yes, I did. Okay, so let's do the other one. All right, so I've given you in this one the information that, all the information that you need in terms of, like, the reaction. It's a precipitate reaction that it says, so, how many grams of chloride ions are in a sample of water if 20.2 milliliters of 0.1 molar silver ion is needed to react with the chloride sample? So this is a result of the titration. So the first thing I want to do when I look at this is it's asking me how many grams of chloride do I need to react with the silver. So I've got information about the silver. Let's use the information about the silver. So I'm going to calculate number of moles Ag plus used in the titration. That's what it's asking me to do. So what do I know about the Ag plus? I know its molarity and I know how much of it was in the sample, so I can use those things. So I've got a volume I can use of 0.0202 liters, and I also know that I have a molarity of 0.100 molar Ag plus, and if it's 0.100 molar, it's 0.100 moles in 1 liter. So I can figure out how many moles of silver ions I have. So I end up with 0.00202 mole Ag ions. Okay, so now I have something, I know something that I can actually use. I'm going to use my moles of Ag plus to get to my moles of Cl minus. So you do that. Do that step and see what you get. So this, I really up here, I answered A. Now we're going to start working on B.
Mrs. Bailey,
Yeah,
it is asking how many grams of chloride is
we're getting there.
Oh,
Before we can find, I don't have any way I can go straight to grams of chloride. I have to know moles of chloride before I can get to grams of chloride. So once we know our moles, we'll use that to find our grams. So what's my mole ratio? 1 to 1? Yes. Now technically, do you see how this puts me in moles of chloride ions? These things cancel out. So I could add another step right here based on what Kennedy just said, and I can put 1 mole of my chloride ions down here, and I can go to my periodic table, and the molar mass of chlorine is 35.5 grams in a mole. So I could just put all that together and figure out how many grams of chloride I need. So what is it? Did you do that already, Kennedy? What'd you get?
I got 0.0717.
Point 0.0717 grams of chloride ions. So really, truly, is that? Yes, that really answers A. I was thinking I was working on B, but I'm really finishing A. That's why Kennedy told me that. All right, now let's work on B. See if you can figure out how to do B. You know how many grams you have? You also could know right here how many moles you have from this ratio. Oh, do you know how to do B? What'd you do? 0.0717 grams chlorine or chloride over what? 10 grams. Gives me a percent. Oh, you know what else we got to do? Times 100, because we're finding a percent. Otherwise, it's going to be really little. So I got 0.717 Cl minus, percent-wise. Now, pull out the other paper I had you pick up today, because I want to talk about some of the problems. 'Cause these examples didn't cover a couple of things. Where did I put it? Okay, so I want to tell you that for every one of these, the first thing you want to do is write the equation. Then once you have the equation written, figure out where do you want to go from there. In most cases, you're going to have to take a volume that's given to you in milliliters, turn it into a volume in liters, then find your number of moles, then use your mole ratio, and then finally calculate your molarity of your unknown. In places where you have two solutions together, like they're mixing and it's, say, 20 milliliters of one and 15 of the other, in the end, when you're finding the molarity of whatever ion or whatever chemical compound you're looking for, you have to combine those volumes when there are two things involved and they're mixing. Like, you know how you put your sodium hydroxide and your HCl together when you were titrating? That was a combined volume. So whenever you have volumes combining like that, when you're calculating your molarity, you have to use that combined volume in the problems. Let me see if there's anything else I need to tell you. No, I think that's it. These are a bit of a challenge. You just have to methodically work through them and see what do I have that I can use to get me something that actually helps me solve this problem. Okay? So we'll break into groups. We'll work our way through them. You may work with a partner if you choose. Doesn't necessarily have to be your lab partner. I really don't care.